Okay, ladies and gentlemen, I need to just discuss a few things. It won't really hurt you on your worksheet, but some information we need to know about fission and fusion. So you can take notes on these if you like, or you can just look over the notes and use them to study from. Fission occurs when you take a large unstable nucleus and you split it apart. It can occur spontaneously when a particle hits a nucleus, gives off a bunch of energy, and then it releases smaller particles. Those are those neutrons we had when we did our balancing of our equations. So in this case right here, if you look at this one, we have a neutron moving slowly that comes in and rams that big uranium-235 atom. Then the barium, well, that splits it, energy's released. One of these wouldn't hurt you if you were around it. It takes a lot of these to make a bomb. Well, there's the barium and the krypton that are formed, and 3 neutrons were produced. So that's called fission. Now, a chain reaction is what makes a bomb. If you'll notice, look what happens. So you got a bucket of uranium, right? All you have to do is come in and shoot in a neutron. If you shoot in a neutron, then this will happen. And look, 3 more neutrons can go and hit other uranium. And if you get this thing going in the right way, you've probably seen those like chain reactions out on the internet of like people doing. We'll try to look at one here at the end of people doing a bunch of mouse traps with this method. So the neutrons hit other nuclei to cause those nuclei to break, result more energy, more neutrons, and this goes until all the nuclei are split. So here's an example of one coming in, hitting this fissionable nucleus. It splits the nucleus. There's the energy, there's the products, and then these can hit another one, and this whole thing starts over again. So that's really pretty simple. Fusion, you have to get the right 2 things to small nuclei and have them run together. And when they do, it doesn't take as much energy to hold them together as it took to hold them together individually. So what happens on that is then some energy is released. You get a bigger particle. In this case, you get from these are different forms of hydrogen, deuterium and tritium, and they make a helium atom, and neutrons given off, and energy is released. So then this could continue to go on forever. So this is how we think the elements got fused in the sun. Is the hydrogen of the sun makes deuteriums, then the deuterium hits itself and makes beryllium, and then another deuterium hits a beryllium, makes a carbon. And you can see real quickly, here are about 10 of the elements being made pretty easily. We can't always explain how these work that easily, but this is the method for making a few of the simple elements. Now, what's the difference between a nuclear power plant and a bomb? Well, when you did your web quest, you talked about control rods. And what happens is the chain reaction can create energy, and they use that to heat up the water that spins the turbines, which was very findable in that web quest. A lot of you had some crazy answer about what the water was going to do. Then the control rods, what they do is they drop those down, and the extra neutrons can't hit the rest of the fuel. So all you do is block the rest of the fuel from the neutrons, and you keep it at a rate that doesn't make a bomb. When Chernobyl went down, they pulled the rods up for too long. It got too hot. It melted the whole reactor, and then the chain reaction essentially went off. They're lucky they just didn't have a nuclear explosion. So real simply, there's where the control rods are in this. This is where the reaction is. This whole thing's buried, all of it in water, this whole system. And then the heat from this reaction heats the water in this part of the system that turns the turbines that makes the electricity. And then the water that comes in through all this gets really hot, and then they run this, they just let this trickle out, and they let that go back into the river or the lake that it's next to. Here where you could have looked here to get the answers to the web quest. Nuclear power doesn't make greenhouse gases like coal does, and your waste for nuclear power is only about a 15th of that of coal, and you don't need as much fuel to get the same amount of electricity. But of course, you got this radioactive waste. That's the kicker. Once you get this thing all up and running and everything, if we could find a way to get rid of the waste, then we'd have a perfect system. Medical advantages: radioisotopes can be used to check for blocked kidneys or other organs. Radiotherapy works because cancer cells can't repair themselves. And food preservation: you can use gamma rays to kill off certain microorganisms in your food. So the radiotherapy, cancer cells grow faster than regular cells. So the radiation attacks the faster growing cells is the hope when we give you some form of a, not chemotherapy, but radiotherapy. Chemotherapy, same premise. The drug kills the faster growing cells than the slower cells. Of course, you can lose your hair. Most of you got these things right. All that's bad stuff that can happen to exposure to radiation. So that's a quick summary of the last things you needed to know. You can start working on your review guides. They will be available as well tomorrow. See you back on Thursday.